All right, let's talk about what happened now. When you plugged it in, turned it on, when you closed the switches, what happened?
The lights were still bright.
They were bright, huh? They were bright. So first, before we get into everything, let's explain about the wiring. I didn't give you all the examples the first time because I wanted you guys to be able to make some mistakes. And don't worry about making mistakes. We're here to learn, and you learn more from your mistakes than you do from everything going right. Okay? So when you wire it, you have to wire it like you read on a ladder diagram. Even though electricity doesn't flow this way, this is how we want to wire it. So we're going to start from line 1. Line 1 is going to go into a switch. And it's really the best to use a highlighter. So once you've wired that, and if you draw it, you can highlight it. Okay, I've done that wire. That one wire is done. Highlight it. Then you come out of the switch into a in this case, a light bulb. I did that wire. I can highlight it. Now I'm coming out of that light bulb home to the other side. Then I can highlight that. Good. That circuit's done. Nothing else goes here. Nothing else goes there. Then I take line 1. Line 1, wherever I get power from, has to go into that switch. Its own separate switch. After that, it leaves that switch, it comes out of that switch, and then into this heat element, light bulb. Out of that light bulb, we're going to go home to line 2, to that one wire that's highlighted. So a total of, we're going to need 1, 2, 3, 4, 5, 6 wires. Does that make sense? So as you wire it like that, even though it looks weird, these wires may be short here, long in the unit, it's okay. So now let's talk about electricity and what's happening. If I close this circuit right here, and I have 120 source volts, what then feeds this light bulb right here? 120 source voltage. It gets its full voltage. That light bulb going to come on?
Yeah.
Full brightness. Now when I close this switch, and in this example, we close them both at the same time, but now I'm also equally getting how much voltage to this? 120. So each individual bulb gets its full voltage. It gets full source voltage. How awesome is that? Now because each one gets its full voltage, they're both fully bright. And that's why both bulbs are a lot brighter. This is called parallel.
Parallel.
Like a train tracks. Notice how it's like a train tracks? Train tracks run parallel to each other. So the rule is
It's a parallel circuit then?
our switches are wired in series. So notice I go into a switch, out of a switch, into the light bulb, out of the light bulb, and home. So my switch is wired in series to that load. Then separately I have another switch that's wired in series to that load. But the loads are wired in parallel to other loads. So in HVAC, we want to make sure that our loads are always wired in parallel I don't know, it didn't look right. Parallel to other loads. You get the gist of it. Switches are wired in series to loads. Loads are wired in parallel to other loads. We want to make sure that everything gets full voltage. Interesting, huh? Mm-hmm. Is that not cool? So now what I want you to do is I want you to check the amps right here on this wire. And then I want you to check the amps right here on this wire. And then what I want you to do is clamp it around both of these wires right here and check the amps here. Ooh. Right, and go.